So I want to do one last solution to a differential equation where separation of the variables is kind of difficult. So we begin with y prime equals 2x plus 5y over 2x minus y. Now if you try and rearrange this into dy by dx equals 2x plus 5y 2x minus y and cross multiply and try and rearrange and separate the y's from the x's and the dy from the dx's and collecting them all together, you're going to find that that's fairly challenging. So this is another case of variable substitution, and we discover, if we have a quick look here, that we can create that y over x scenario that I mentioned in an earlier video by multiplying the right-hand side of the differential equation by 1 over x and 1 over x, top and bottom. And that generates dy by dx equals 2 plus 5 times y over x over 2 minus y over x. And now we do our variable substitution. In our variable substitution, we're replacing the y over x, and it looks like this when we do it. We have that we're going to let u equal y over x, and that implies that y is equal to u times x. Taking the derivative of this, dy by dx of that is u plus x du by dx. That's by the product rule. You're differentiating this with respect to x. So we will replace every y over x in here with a u, and the left side dy by dx with this expression. And we end up with the following situation, where we have u plus x du by dx equals 2 plus 5u over 2 minus u. Now, if we rearrange this equation, getting u to the far side, and then getting everything over one denominator, we get to this situation where we have x du by dx is 2 plus 5u minus 2u plus u squared over 2 minus u. That further simplifies, and it looks something like this, where this expression up here becomes u squared plus 3u plus 2, and this denominator comes upstairs to be 2 minus u du. And now I've got my variables separated, so I've got this expression on the left and 1 over x dx on the right. Now when I look at this, I say, boy, that looks like that's probably a partial fraction situation. So what I need to do is further factor this. So I have 2 minus u over u plus 1, u plus 2 du equals 1 over x dx. And at this point, I'm going to use our partial fractions technique to separate this into two fairly easy fractions to integrate. So we begin by saying 2 minus u over u plus 1 u plus 2 is just an a over a u plus 1, b over a u plus 2. Now by cross multiplication, we get that 2 minus u is a u plus 2 plus b u plus 1. So that's just multiplying through by this denominator. Then we can set two conditions that will make this term 0 and this term 0, and they're the following. When we let u equals negative 1, this term vanishes and we get a equals 3 when we substitute. When we substitute for u equals negative 2, then we get this expression. We get that b is equal to negative 4. So that changes our integral to simply the integral of 3 over u plus 1 minus 4 over u plus 2 du equals 1 over x dx. And we're almost finished at this point. When I integrate both sides, this is what comes from it. I get 3 ln absolute value u plus 1 minus 4 ln absolute value u plus 2 equals ln absolute value x plus, and I'm going to call it C1 for now. Now I'm going to use the rule of logarithms, bringing the 3 up to an exponent and the 4 up to an exponent here, and I'm going to get the ln x to the left side of the equation. With that, I can use my rules of logarithms. When I'm adding and subtracting logarithms, they turn into products and quotients. So this turns into ln absolute value u plus 1 to the 3 over x u plus 2 to the 4, and that's all equal to C1. So from there, what I do is I take that expression and I'm going to take it out of logarithmic form. So that's my next step. I'll take it out of logarithmic form and I get u plus 1 cubed over x u plus 1 to the 4 is plus or minus e to the c1. And at that point, I can just arbitrarily call e to the c1 a new superconstant c, and I'm going to multiply top and bottom by x cubed. You'll notice I've taken my u's and replaced them back with y over x's. When I multiply through by x cubed, that comes inside, this comes inside, this comes inside, and I get just that y plus x cubed over y plus 2x to the 4 equals c. Bit of a hefty question, but it's got a really nice solution when we're all done.